do room correction, with a device, or you can do echo or audio. Typically, all that's done with like a chip called a digital signal processor. So for a few years, I worked on compilers for digital signal processors. Um, let's see, what else I've done. Took a couple of side detours. I took a 3-year detour into finance, stocks, and commodities and futures trading is an interest of mine. So I worked with a commodity trading advisor doing writing trading strategies. So that exploited my software, background. So that's something I just like to do on the side. I follow the markets, so that's a big interest of mine. So did that a little bit. Then after that, sort of got back into compilers. I worked for ARM Holdings, a UK company. May not have heard of them. Most people haven't, but essentially, if you have if you have a cell phone, their chip is probably in your cell phone, driving it, an iPad, that sort of thing. So I worked with that compiler team for a while. So pretty long career in compilers, little detour in finance, but pretty much the trajectory has been compiler development. So.
It's amazing. I also want to let everybody know we're here with Michael Collison, who's heading up the JIT compiler, and also you're working on EVM, the RS EVM, right?
Well, that's mostly Mike Keller. I mean, essentially, I do the JIT compiler, plus I'm the lead, the tech lead for the compiler team. So anytime, I tell them, I said, don't bother the guys if you don't know where the schedule is or things like that. Come to me, and I heard the cats. So that's the other thing that I do. So I've done that in my career as well. So I'm managed compiler teams.
You've worked on compilers in defense Raytheon situations.
Mm-hmm.
And now you're working on compilers in a public blockchain.
Mm-hmm.
Are the stakes just as high? How does it feel? Like, what is the difference to you?
Let's see, are the stakes just as high? No, the stakes are not quite as high. They're still high because, obviously with Raytheon, you might have been working on a compiler for a board that's going to go into a missile system, as an example. I'm not saying it did. And if you got the code wrong, the missile could, it could misfire, it could land someplace where it shouldn't land. So the stakes are pretty high, right? That the compiler generate correct code there. Here, in the blockchain, the stakes are high because, with smart contracts, where we're eventually going to get to, we're moving money around. So you don't want to be wrong there either, right? We don't want to incorrectly transfer money or not transfer money or do other things incorrectly. So the stakes are high. Stakes are high as well because, instead of running on one machine, you're running on thousands, potentially tens of thousands of nodes, right? Simultaneously when a smart contract executes. And so we want to make sure that we don't allow things like denial of service attacks, right? So we don't want an attacker to inject bad code. So that's something that attackers will definitely try to do, once the chain gets more mature.
And I like that you brought that up, the attacker part, because one of the conversations around Ethereum Classic, its value proposition, when I explain to people that, look, if you're a supporter of Bitcoin, you might also want to take a look at Ethereum Classic. It has a lot of the same security properties, but it's also Turing complete. Now you bring up that some of that Turing completeness creates an attack vector.
Mm-hmm.
Could you give us a little bit more detail about that?
Yes, I mean, basically, think of it this way. So the EVM at its lowest level is nothing but a series of bytecodes. When you look at the individual instructions, it's nothing more than a series of bytecodes. And there's an agreement, right, that has been made that says, well, an add has this opcode, subtract has this opcode. And so, within the just-in-time compiler, as an example, where I'm going to be turning the bytecode into machine code to make it execute faster. What if an attacker maliciously injects some code that I think might be an add instruction, but he's actually getting me to do something else, or he's getting me to jump into the middle of some code where he can actually take control of the user's machine, right? Because I'm going to translate that bytecode into machine code and I'm actually going to store it into a region of memory on the user's computer and execute it. So I could actually be harming the user's computer potentially if we allow that attacker to gain control. So there's things that we can do, and there's a lot of research in the field. Unfortunately, there's a trade-off, right? The things that you can do to absolutely guarantee that hacker gain control take a really long time to run. And so the users will say, "Why is my program taking so long to compile?" And then on the other end of it, you can do nothing, but you don't want to do that. So there's a trade-off in terms of different techniques that you can use to prevent attackers doing malicious things. So
is that why also we're looking at JIT? Is that a move towards speed and a sacrifice of security? What?
No. The whole point of the JIT is, if you think of what happens today with EVM programs, they're what are known as interpreted. So the EVM is one of the things that makes it challenging is arithmetic is 256 bits. So if you want to add 256-bit numbers, the only way to do it is, and let's say that your EVM is written in something like Rust. Well, Rust doesn't have 256-bit arithmetic. So you actually have to write an algorithm. You have to write a function to do a 256-bit add. Can you imagine how slow that is?
Yeah, I was
right. Exactly.
That's one of the worst parts, is that you have to do all this complex calculation for basic math.
Right. So now with the JIT, what we can do is we still have to do 256-bit math, but we can actually translate that into the native code for, let's say, an x86 machine. Now, it'll still be a lot of instructions compared to, let's say, a 64-bit add, which might only be 1 or 2 instructions, but we might be able to do a 256-bit add in maybe 12 to 14 instructions. Yeah, I'm talking off the top of my head, but compared with what you'd have to do in Rust, the time to execute that would be significantly faster.
Right. Yeah. And now in getting that speed with the JIT, what are you losing? What's that trade-off?
Well, I mean, it's a little easier. It's potentially easier for an attacker to try and gain control of the user's machine, right? Because you're actually generating machine code and you're actually writing into an area of the user's memory, and we're saying, hey, jump to that area of memory and now go execute this program. So we're potentially giving them access to an end user's machine or a server or whatever. So we have to be very careful, right? Because what the JIT does is it generates machine code, right? And then essentially it generates a new function. And then it tells the EVM, okay, now go execute this, but it's just going to execute a lot faster. And so if we don't do things correctly, or if we allow an attacker to do some evil things, he may be able to gain control or do some malicious things that we don't want him to do.
And this desire, obviously to protect, you've always had this. It's not unique to being a blockchain compiler, right? No. Always compiling, that's something you've wanted to do. What do you think is unique about working in blockchain compiling versus your previous experience?
Sure. Traditional compilers and that I've worked on, you typically, let's say, would be on a Linux machine or a Windows machine, and you're usually compiling for that target. So let's just say, my experiences with GCC, and let's say I just wanted to write a Linux program, I compile it, for the Linux machine, for the x86 program, and it just runs. Now, let's say that I generate wrong code for the program. Well, the program may give wrong results. It may crash, but it's limited to my machine. Now imagine I do that on 1,000 nodes. I could lock up 1,000 nodes. I could do some, I could cause the computer's machine to reset. So we just don't want to do that. So the stakes are a lot higher because you're doing the same thing simultaneously in hundreds or thousands of places all at once. So the stakes are a lot higher.
I see. So it's the fact that the network is comprised of so many different computers that
running the same thing, right? Yeah. In order to reach consensus, right? They all have to, essentially, they're all going to execute the same smart contract to reach consensus and make sure you get the same result. So if you give a wrong result or you do something bad, the stakes are high.
Right? Yeah, I've always enjoyed explaining to friends of mine how random is calculated on the block, since you need to have the same result,
right,
on every node. So what attracted you to Ethereum Classic?
I would say, can I be honest? When I first took the job, I didn't know the difference between Ethereum Classic and Ethereum. It was only like as I was starting to do the research before I started, I was like, what is this split and this fork? And I was like, oh, okay, wow. But the attractiveness for me was I wanted, one of the things in my career is that I need to be challenged, constantly challenged. I'm not a guy that, oh, solve the problem once and just kind of sit back and fix bugs. I then need like the next challenge. So I've done traditional compiler stuff on the desktop for years, and blockchain was just completely different. The Ethereum virtual machine is different from anything that I've ever worked on. As what we call a compiler target, meaning that you're generating code for something. That's what we call a target. And 256 bits. It's a virtual machine. Also, the opportunity to work on LLVM. I'm not sure if you know, but LLVM is a very robust, retargetable compiler infrastructure, open source. Most of my career has been with GCC, but I've did a little bit of LLVM before I came to Ethereum Classic Labs. And LLVM is just a lot easier framework to do non-traditional compilers, meaning a compiler that you want to embed, or if you want to do a just-in-time compiler, it doesn't lock you in the way other compiler architectures do. So that was very attractive. So, and then the whole idea of the blockchain and learning something new skill set. So though I would say those are the main components.
And that's what brought you here. What's keeping you here? Why? I see that you're active. I know that from people who give answers, you always tend to have very eloquent and at the same time very focused responses. So I know that your contributions to the community are very important. Is that part of why you stick with the Ethereum Classic? Is it also because it has the same kind of morals or ethics that you do? What else is it around the non-technicals that?
I mean, once I understood, what had happened, it was important to me to be part of the community that quote unquote didn't fork, that stayed true to its original values. I thought that was something that was attractive. Secondly, I like the community. In general, I prefer openness, transparentness. The fact that we get to work out in the open. So when I push my changes out there, anybody can see them. They're on GitHub. People can review them. People can also be part of this community. So being part of the community was also something that was important, and also just the opportunity to get in at the ground floor. I would say that's the thing that keeps me here, because essentially I think of it as we're building out the plumbing.
Yeah.
For if you want to call it the next generation internet. So this is really early stage, right? We're really the pioneers, but pioneers get arrows too in their back. So. It's exciting to be part of that. So,
and I know that also the team is learning a lot from working with you. I mean, 25 years of compiler experience is hard to find. What's that like? You've got a unique colleague in Jake Lang, who he's not only super young, he also works on an Ethereum project. What has that give and take been? As far as the experience gap, and what you can teach, what you can learn, and then also the learning between Ethereum and Ethereum Classic.
Yeah, I mean, he brings a lot of experience and background, to Ethereum. For example, he's mentioned a few things to me in terms of EIPs and things like that. There was one he mentioned to me recently, so it's been helpful to just understand how the Ethereum organization works, because as we do upgrades like Constantinople and Byzantium, those things are important, that we maintain compatibility. And, I find it refreshing. I like learning from people, even if they're young, and they can learn something from you. And sometimes people can bring a different perspective that, us old guys that don't have, and I'm going to include you in that.
Yes.
So he's brought a good perspective and fresh perspective, and also with using Rust, that's been the other thing that's been interesting, learning a new language like Rust. So because I've been a C, C++, Java guy for most of my career. So,
Yeah,
um,
Rust
mhm.
is very, is it predominant? Like why do I see it mentioned so often in our documentation?
Well, I mean, Sputnik VM is written in Rust.
Right.
So, that's the main reason. And so, of course, the just-in-time compiler, which is going to be part of Sputnik VM, is also being done in Rust. So,
And is
uh,
that because we also see developers are more comfortable with that language?
it depends on who you ask. you know, uh, if you ask me, whoever, I'm not sure who originally wrote Rust. Wrote Sputnik VM, but I think they just happen to like Rust. That's what I see in developers is like, oh, this is a language I like, and so that's what they, happen to write things in.
I think that's more of like a decentralized kind of like not approach, but externality of the way things are run in the governance. That hey, let's write it in Rust. Why not? Like because I feel like there's just so many different compilers. There's the EVM, the Sputnik, the LLVM. It sometimes feels like we're building multiple flavors to do the same thing.
Well, that's definitely true with the clients, right? You've got the Go clients. I think the Ethereum client is written probably in C++. As I said, it's whatever those developers happen to like, or whatever they've been exposed to. You know, like I said, I have a bias towards C++, but
Right.
you know, uh,
You're
it's
comfortable
it's
with
it's good to learn a new language and get to see what approaches other languages take. So Rust is interesting from that standpoint.
And now Atlantis puts Ethereum Classic on a similar roadmap to Ethereum.
Hmm.
What do you think happens after? Is there a particular area you see kind of pivoting, becoming the focus of interest for Ethereum Classic?
Well, we're going to want to do, we're going to want to maintain compatibility. As I said, one of the things I'm keeping an eye on is something called EIP 615, which really will bring support. If it's assuming it's approved and Ethereum Foundation does a hard fork around it, I would
What's
definitely like to. Yeah, so basically, it adds new opcodes to the Ethereum virtual machine that make it a lot more suitable for other high-level languages. So one of the things it adds is an opcode for subroutines, opcodes for static jumps. So today, jumps are only indirect jumps, and that makes it difficult to do things like analyze control flow. So that's one of the malicious things an attacker might do. Whereas if you only use static jumps, you could tell exactly in analyzing the program where the program is jumping to. So imagine somebody could do an indirect jump and they could actually jump into the middle of an instruction that they patched, and maybe they could then go someplace else and do something malicious. Whereas if you had only static jumps, you could analyze where the jump is going and say, oh, okay, this is actually jumping to a real place. And this is a real instruction. So you can do some analysis there.
And what do we lose by having static jumps?
Excuse me?
What do we lose if we have static jumps?
Well, they're talking about deprecating indirect jumps as opposed to eliminating them. But so, for example, if I don't know if you're familiar with C or C++ or any what high-level languages you program in, but switch statements. So typically, if you have a large switch statement, that's typically done using indirect jumps in the assembly language. So what they'll do is imagine a switch statement with, I don't know, 100 entries in it. What they'll do is, you could have a jump table and you could just load up a register and do an indirect jump to the proper place in the switch. So that's one of the things that you could lose. You'd have to do switch statements a little bit differently if you end up deprecating them. So.
We definitely got a little bit deeper than I expected, but
Well, you asked me what do we lose. So.
But this has been a fantastic understanding of that, and trying to also see through your eyes the continuation of etc ETH. I love the fact that you're focused on compatibility. I think that interoperability is the new way forward for a lot of these major projects. And there's a lot of interest in what's happening with some of the side chains, also some of the side projects like Cosmos and Polkadot. I don't know if you've been keeping up with some of the other ancillary ones.
Not as much of that, not as much with those. I'm really interested in getting other languages supported for the EVM. So that's why I want to, if that's why I'm keeping an eye on EIP 615, because right now the way the EVM is architected, the spec for it, it's really hard to support general purpose high level languages like C and C++ and Rust. You would have to put a lot of restrictions on them. If we do that, and I need to get into it a little bit more, I think we'll be able to support other high level languages like Rust, like C and C++. And so I'm focused on bringing a whole new set of developers in the blockchain if we can expand language support to those other languages. So.
And that's accomplished by the inclusion of opcodes, or is that separate?
It's really two things. So the first thing that we're doing is, so we're doing, in addition to the just-in-time compiler, we're doing a true target for the Ethereum virtual machine within the LLVM framework. So today, LLVM can generate code for an x86, for an ARM, or PowerPC, and probably 20 or 25 other processors. Well, we're going to add the Ethereum virtual machine as a target. Okay. And typically what happens when you do that is then you seamlessly get support for what's known as front ends. Compilers are typically broken up into the front end and the back end. The back end is the part that does optimizations and code generation. Front end is the language support. Read in C or C++, make sure it's correct, generate any warnings, generate any errors. And then if that's correct, you pass it in some intermediate form to the back end. So typically, once you have your back end done, then if there's an existing front end, then it just works. But the EVM, because of limitations in EVM 1.0, you can't really support typical languages like C and C++ out of the box. You'd say, well, you can write this subset of it, but you can't do generic C and C++. If we get support for static jumps and calls and functions and things like that, you'll be able to support those languages a lot easier.
Okay, so this is EIP
615.
615. I'll make sure to link.
Yeah.
And that's a great talking point. I'm so focused on the Atlantis hard fork. Forget that we also should be looking at some of the proposals happening in Ethereum to kind of predict where our roadmap is going forward. So to switch gears, before we kind of wrap up, I wanted to get a sense of where you think we are educationally, bringing non-blockchain users into using blockchain. How many years out do you think we are right now?
Yeah, I mean, I think that's a challenge. We can do a better job. Essentially, I think right now, bringing a non-blockchain person in, it's almost like the assembly language days, right? When I first started programming, I was programming in hex and an assembly language, and it feels that way. I mean, we do have high-level language support and things like Solidity, but there's so many things that someone has to do to set up a test network, to set up a wallet and do things like that. And my view is, we need integrated development environments that hide a lot of that complexity as much as possible. The things may need to be done, but you want to minimize what the user has to do. So I think we're a little ways out that we need to do a better job with integrated development environments. We need to do a better job with language support, as I've already mentioned here, beyond Solidity and Viper. I really think we have to support other languages to bring other people in.
Is there a language you have that you see as being the next critical jump?
It's not so much any particular language as much as just generic high-level language support. I mean, I know I've had a lot of people say to me, I want to write smart contracts in Rust and C and C++. I mean, those are the three that just immediately jump to mind. And essentially, we want to give people choices. I'm not suggesting that we deprecate Solidity or anything like that. It's just that the number of people that know Solidity is relatively small.
Yeah, and I think that when we look at the solutions we're finding continuously, grow the option set, right?
Exactly.
Build the foundation, and like the work we're doing with OpenRPC, for example, it's all foundational. It's going back to the beginning, making sure that's easier and easier to bring in new devs, wider acceptance of different programming languages and styles.
Exactly.
And I think it all speaks to the interoperability between chains and the work we see across them too.
I agree.
Excellent. Well, Mike, this has been fantastic.
Okay, thank you, Dean.
Did you want to leave our viewers, our audience, with any words of wisdom?
No,
I'm
not that smart.
A generic, don't trust, verify.
Exactly.
That's
exactly.
always the greatest.
I like that. There you go.
Awesome.
Okay,
Mike,
Dean.
take it easy. Everybody,
all right, take care.
Thank you. Take care.
Yep. Bye.